Alright, welcome to our video on polynomial long division. This is one of the most difficult things that we do in Algebra 2, so it's really important that you are focused with us today. If you need to look at something again, stop the video, rewind, go back and watch it again. One of the big reasons that people have trouble with polynomial long division is they haven't done long division a lot in a while. So actually I wanted to start with just a regular old elementary school division problem of 1753 divided by 6. Remember, when we divide, we're trying to think about, well, how many times will 6 go into this number? Well, 6 doesn't go into 1, so we jump right to the 17. And we think, well, what's 17 divided by 6? Well, it's not more than 2. So 6 will go into 17 twice. And then we'll multiply. Take that 2, multiply it by 6, and then we subtract. 17 minus 12 is 5. Once we get that 5, we take the next number in the divisor or the dividend, whichever one's in the house, bring that number down. So now we have a 55 there, and we repeat the process. 55 divided by 6, well, it's 9 or so. All right, 9 times 6 would be 54. We subtract, bring down our 3, and repeat the process again. 6 will go into 13 twice. And then, well, this didn't divide evenly. We had 1 left over at the end. Dealt with this a few ways. Back with regular numbers, sometimes you put like a decimal point and some zeros, try to get a decimal answer. Sometimes you just write, hey, this is a remainder. Just write remainder 1. The way that we're going to see this work with polynomials most of the time is, we would have called this 1 over 6. We said this 292 and then 1/6 would have been our final answer there. So, quick reminder on how we divide any kind of numerical expression. And now I want to talk about how we would take two polynomials and divide. We've added, we've subtracted, we've multiplied already, saving division for this last video. All right, so let's take a look at the next problem you have there on your notes. We're trying to divide this cubic polynomial, this third-degree polynomial, by x minus 2. Right? Just like we did with the numbers, our first step is to figure out how many times, well, we'll just say how many times does this go into this, just like how many times does 6 go into that whole number. When we're dealing with polynomials, you only have to worry about the first term in both the divisor and the dividend. You only have to worry about the x cubed in here, and you only have to worry about the x out here. So what we're really thinking is, how many times does x go into x cubed? And it's not 3. It's the most common thing that people say that's not correct, is that 3, because you kind of see that 3 there. But remember, what we're really asking about is division. What we're really asking is, what is this divided by x minus 2? And I said you're only worried about the first term. So what is x to the third divided by x? Well, x to the third divided by x would be x squared. So we say that x goes into x cubed, x squared number of times. That's division. X to the third divided by x to the first would give us x squared as part of our quotient, as part of our answer. Okay, so once we've done that, just like we did 6 went into 17 twice, we put that 2 up on top as part of our answer, and then we multiplied. We did 2 times 6. We're going to multiply here. We're going to multiply this x squared, and now we're going to multiply by this entire expression out here. We're going to do the x squared times x minus 2. Right, so we're going to do x squared times x minus 2. Well, that would be x to the third minus 2x squared. That's what goes down here. X to the third minus 2x squared. All right. Then remember, we had 17 minus 12 to get our 5. We subtract at this point. So we are subtracting this expression from this expression. You have to be really careful with the signs here. Remember that you are subtracting this entire expression. I would strongly recommend putting that in parentheses so that you remember that. You're subtracting each term separately, like we talked about in the last video. When you subtract, you're like distributing that negative sign through there. So we do x to the third minus x to the third, we get nothing. That's good news for us. That means we've divided as much as we can into that expression. Then we have a negative 9x squared minus a negative 2x squared. That's a negative 7x squared. You can watch your signs there if you're subtracting a negative. Okay? So we've gone through our first step. Just like with the regular numbers, our next step is to take the next, in this case, next term, or the next number in the last one, take the next term, drop it down, and repeat this process. Right? So now we want to figure out how many times x minus 2 goes into this expression. Again, just worry about the largest degree terms. Worry about the x going into the negative 7x squared. We think, all right, well, negative 7x squared divided by x, that would be a negative 7x. Right? X will go into negative 7x squared, negative 7x times. All right? Again, division. This divided by x. Now we go back and we multiply the negative 7x times this expression. I'm doing this over here just so you can kind of see the steps worked out. You may get comfortable enough that you don't have to do these calculations off to the side. You can just do them right within the problem. Just kind of want you to see each step here. So we're multiplying here. This is negative 7x squared plus 14x. That goes down here. And again, we are subtracting. And again, I recommend putting the parentheses there so that you don't lose a sign. Negative 7x squared minus negative 7x squared is nothing. That's good. If you've done this correctly, that first term is going to cancel out when you subtract. And then we've got 26x minus a positive 14x is a 12x. All right, one more term in our polynomial. Drop that term down. Let's do this one more time. X goes into 12x, well that's just 12 times, right? So we're just doing 12x divided by x is 12. So a positive 12 goes up here in our answer. Multiply 12 times x minus 2. Be 12x minus 24. So 12x minus 24 is going to look like that. And let's see, we subtract. So subtracting this whole expression. 12x minus 12x cancels out again. That's good. Be careful here. 28 minus a negative 24. You're doing 28 plus 24. We've got 52 left over here. This is a remainder, just like we had that remainder of 1 in the regular numbers in our warm-up problem. You know, x won't go into 52. If I say 52 divided by x, that doesn't simplify. Right? So we take that 52, we treat it like a remainder. So you might see, like maybe in the book or something, you might just see it written as R52, remainder of 52. What we're going to do, it's a little bit more precise mathematically, is to take that 52 and make a fraction along with that x minus 2. So at the end we're going to say, okay, well we've got an extra 52 over x minus 2. At the end. Just like we took the 1 that was a remainder in the warm-up problem, we did 1 over 6. We're going to do this 52 over the x minus 2, right? And this is what our answer looks like. This is our quotient. This is what happens when we divide this by x minus 2, right? So there's your first look at a long division problem. I wanted to show you another type of division problem with long division, where we're not just dividing by a linear term, we're not just dividing by an x, but we're dividing by an x squared. And so we'll see that here on the next one, where we're taking this polynomial dividing by x squared. Again, we're looking at division. So look at the largest term going into the largest term. The largest term, 2x to the third, divided by the largest term out here, x squared. Right? So 2x cubed divided by x squared, that's going to be 2x. Right? 2x is going to go here. There's our 2x. Then we multiply. The process is the same here, even though it's an x squared. We're just, when we get to the end, there'll be a little bit less we can simplify. Right? So we're going to do 2x times our x squared plus 3. All right, that's going to give me 2x to the third plus 6x. Now notice if I do plus 6x, that's actually going to line up over here with the 8x. So I want to try to arrange these. I want to try to get it organized so that we have like terms that we're combining when we subtract. So that right now that negative 5x squared is just going to come down. Right, so we're going to subtract this expression. The 2x cubes will cancel out, that's good. Now this negative 5x squared, we're not subtracting anything from that. So that remains a negative 5x squared. Here we have a plus 2x, all right? 8x minus 6x. We can go and bring down the plus 11 also if you like. And then our next steps are repeat this x squared going into negative 5x squared. Well, that's going to go in there negative 5 times. Again, what I'm thinking about is what's negative 5x squared divided by x squared. All right, and that would be negative 5, which is part of our answer. We multiply again. So we're going to do negative 5 times this expression. We're going to do negative 5 times x squared plus 3. Well, that's going to be negative 5x squared and then a negative 15, like that. Okay? Notice again the 2x doesn't have anything to combine with. We're going to subtract. So again, lots of negative signs to keep track of. Negative 5x squared minus negative 5x squared. Cancels out again, that's good. 2x minus nothing is still 2x. And then 11 minus a negative 15. Watch your signs there, that's a 26. Now we'd like to go ahead and do one more step here, but you'll notice our next step would ask us how many times x squared goes into 2x. Or in other words, what's 2x divided by x squared? 2x divided by x squared. I mean, that would simplify to 2 over x, but it wouldn't simplify to a whole term. We would still have a fraction in there, so we can't even do this step. Basically, we're done. And this 2x plus 26 acts as a remainder. We just say this is plus this 2x plus 26 over x squared plus 3. And our answer is just going to be that. Right? So once your degree here is smaller than your degree here, there's no more dividing you can do. We can take x squared into x cubed. We can take x squared into x squared. But you can't take x squared into x. You can't take x squared into a constant. So once you get down to this expression is a smaller degree than what we're dividing by, then we're finished with the problem, and this is just a remainder. So it's possible to have a remainder with a variable in. So it's a little bit different than what you would maybe expect. So there's a couple examples there of long division. We'll do a lot of practicing of this in class. Go ahead and watch this one more time if you're not quite sure how those examples worked, and we'll practice tomorrow.